Create a new scenario with the default start time and a 1-second stop time. Click Create a Scenario. Give your scenario a name such as STK Volumetrics. Keep the default start time. Change the stop time to +1 second. And then click OK. I will not require the timeline view at the bottom of the screen, so I'm going to click Close. I'm going to maximize the 3D graphic window due to the fact that most of this scenario I will view in 3D. Save your scenario. The first step is to enable terrain for both analysis and visualization. In this scenario, I will use the internet, and therefore I will use Terrain Server. Go to the object browser, right-click on STK Volumetrics, and select Properties. Browse to the basic terrain page. Ensure Use Terrain Server for Analysis is enabled. Go over to the right where you see Advanced Analysis Operations and enable Azimuth Elevation Mask, and then click OK. First, we will identify our operations area by using an area target. Return to the Insert STK Objects tool. Select Area Target as your object, and select Area Target Wizard as your method, and click Insert. Give the area target a name such as Operations Area. The area type we will use for this scenario is an ellipse, so change it to an ellipse. On the right, change the semi-major axis to 1,500 kilometers. Change the semi-minor axis to 1,500 kilometers. Drop down to where you see centroid. The latitude of our centroid will be 46.6 degrees, and the longitude will be minus 122.3 degrees. Again, latitude 46.6, longitude minus 122.3, and then click OK. Next, we will use a place object in which we will use to view our volumetrics volume when we create that later in the scenario. Select Place as your object, from City Database as your method, and click Insert. In the name field, type Morton, M-O-R-T-O-N, and then click Search. In the results field, select Morton, Washington, and then click Insert. You can close the Search Standard Object Data window. We are going to tell Morton to use the terrain for analysis. So return to the object browser, right-click on Morton, and select Properties. On the basic position page, ensure Use Terrain Data is enabled. Drop down to Height above ground, and we are going to raise the place object 20 feet off the ground. Basically, we're simulating the height of a building. So type in 20 FT for 20 feet. Click Apply, and then browse to the basic Azel mask page. On the basic Azel mask page, change Use to Terrain Data and enable Use Mask for Access Constraint. And then click Apply. And then click OK. In the 3D graphic window, we're going to zoom to Morton. So in the object browser, right-click on Morton and select Zoom to. Depending on your internet speed, it could take a minute for both terrain and the big maps to render so that you can see all the detail in the area. When it's finished, you can view the mountainous terrain around the city of Morton. Next, we are going to create a sensor object that we will use later on to constrain our volumetric object. So return to the Insert STK Objects tool, select Sensor as your attached object, insert default as your method, and click Insert. In the Select Object window, select Morton, and then click OK. Open the properties of your sensor. Change the sensor type to a complex conic, and change the complex conic half angle outer value to 180 degrees. And click Apply. Browse to the Constraints Basic page. Enable Azel Mask and click Apply. Your sensor will use the Azel Mask file you created in its parent object, Morton. To view the sensor and how the sensor is being blocked by the mountainous terrain, go to the 2D graphics projection page. In Field of View, enable Use Constraints. Select Azel Mask, and then click Apply. Browse to the 3D graphics projection page. In the space projection field, change the value to 50 kilometers. And then click OK. In your 3D graphic view, zoom out into space a few hundred kilometers. As you can see, the Azel mask is blocking your sensor's field of view. That's why the edges of the sensor are jagged. Also, you're viewing this up to an altitude of 50 kilometers. Even though the sensor can go past that, this is what you're viewing it as.